Another round of monsoon rain is moving across the country. Dark skies, torrential rainfall, water rushing through streets, rivers rising, and emergency crews watching the situation closely. But here's the part that matters. This story isn't simply about how much rain is falling. It's about how much water has already fallen, and what happens if the atmosphere keeps sending more. Because when Pakistan's monsoon becomes extreme, the rain is only the beginning. The real danger can develop afterward. In the soil, in the mountains, in the rivers, and inside cities where drainage systems can be overwhelmed within a matter of hours. So the question isn't just, how much rain is Pakistan receiving? The bigger question is, how much more water can the country absorb before the next storm arrives? And that is where this monsoon becomes much more complicated. Pakistan's monsoon is not simply a period of bad weather. It is one of the most important parts of the country's climate. Rainfall from the monsoon helps support agriculture, reservoirs, rivers, and communities across the country. The water is essential. Pakistan needs it. But the same water that supports millions of people can become dangerous when too much arrives. Too quickly, in the wrong place, or repeatedly over several days. And that's the first thing to understand. Flooding isn't determined by rainfall alone. It depends on what happens to that rainfall after it reaches the ground. Imagine a storm moving over an area. At first, the soil absorbs some of the water. Streams begin carrying runoff away. Drainage systems handle the flow. Rivers receive additional water, and everything may appear manageable. But then another storm arrives, and another. Now the ground has less capacity to absorb water. More rainfall becomes surface runoff. Streams rise faster, drains fill faster, and rivers begin receiving water from multiple directions. The atmosphere may be producing the same rainfall, but the ground is no longer responding the same way, and that's where a dangerous feedback begins. Rain falls. The soil gets wetter. Runoff increases, rivers rise, then another storm arrives, and the cycle starts again. This is why the timing of rainfall matters so much. A single intense storm can cause serious flooding, but repeated rainfall can create an entirely different situation. The first storm changes the conditions for the second changes the conditions for the third, and eventually, rainfall that might have been manageable on its own becomes much more difficult to absorb. Scientists often refer to the rainfall that happened before a new storm as antecedent rainfall. The name sounds complicated. The idea isn't. It simply means what happened before matters. If the ground was already wet, the next storm doesn't need to be stronger to create more runoff. It may only need to arrive at the wrong time. And that brings us to one of Pakistan's biggest geographic challenges. The country isn't flat. In the north and west, enormous mountain ranges rise above valleys and settlements, and mountains change how water behaves. When intense rain falls on steep terrain, water can move rapidly downhill. Instead of soaking slowly into the ground, some of it becomes fast-moving runoff. It enters streams. Streams feed rivers, and valleys can channel water into narrow corridors. This creates another hazard, flash flooding. A flash flood doesn't wait patiently for a convenient time. It can develop quickly when intense rainfall produces sudden runoff, and in mountainous areas, the distance between heavy rain and dangerous water levels can be surprisingly short. But water isn't the only thing that can move. Saturated slopes can become unstable. When soil becomes heavily soaked, the strength of the ground can change. On steep slopes, that can increase the possibility of landslides. Roads can become blocked. Mountain communities can become isolated, and emergency crews can face a difficult problem. The places that need help may also be the places that are hardest to reach. A road blocked by water or a landslide isn't simply a transportation problem. It can delay food, it can delay medical assistance, it can delay evacuation, and it can isolate entire communities. But now comes another important part of the story. The water doesn't necessarily stay where the rain fell. Imagine heavy rainfall occurring hundreds of kilometers upstream. People downstream may not experience the same storm. The sky might even be clear, but the water is still moving. Tributaries collect runoff. Smaller rivers feed larger rivers, and that water continues downstream. This creates one of the most important facts about major floods. The end of the rain does not necessarily mean the end of the danger. The storm can move away, the clouds can disappear, the streets can stop receiving rain, and yet river levels can continue rising because the water is still traveling through the system. That's why flood monitoring isn't simply about looking at the sky. Scientists and authorities also watch river levels. They monitor rainfall, they examine upstream conditions, they track reservoirs and tributaries, and they try to understand where the water is going next. Because a flood can be a moving problem. And that brings us into Pakistan's cities. Urban flooding works differently from river flooding. You don't necessarily need a major river to overflow before a city floods. Sometimes the problem is simply too much rain arriving too quickly. Roads become channels, drains fill, low-lying areas collect water. Traffic slows, and eventually, the drainage system can't remove water as quickly as the atmosphere is delivering it. Think about pouring water into a sink. A small amount disappears immediately, but keep pouring faster than the drain can handle, and the water begins accumulating. A city can experience something similar. The drainage system has a certain capacity. The rainfall has a certain intensity. When rainfall exceeds that capacity, water begins accumulating, and the longer intense rainfall continues, the greater the problem can become. This is why the same rainfall total can produce very different outcomes in different places. A rural area with permeable ground may absorb more water. A dense urban area covered with roads, buildings, and other hard surfaces may generate much more runoff. So when the monsoon becomes intense, the question isn't only how much rain fell, it's also where did it fall, how quickly did it fall, what was the ground like before it arrived, and where does all that water go next? Now zoom back out, because this isn't just one storm. The atmosphere can continue feeding moisture into the region. Monsoon systems can interact with areas of low pressure. Atmospheric instability can produce repeated thunderstorms. Moisture can move over large distances. And under the right conditions, storms can repeatedly develop over the same broad regions. That creates a dangerous possibility. You don't necessarily need one gigantic storm. You can create serious flooding through repetition. One storm, then another, each one adding more water to a system that hasn't fully recovered from the previous rainfall. And this is why the ground itself becomes part of the forecast. At the beginning of a wet period, some rainfall can infiltrate into the soil, but as the soil becomes saturated, its ability to absorb additional water decreases. More rainfall becomes runoff, and that runoff enters streams and rivers. So imagine 3 consecutive days. Day 1, heavy rain, the ground absorbs some of it. Day 2, more rain, the ground is already wetter, runoff increases. Day 3, another intense storm arrives. Now the ground has far less capacity. The same rainfall intensity can produce a much larger surface response. That's the hidden danger of cumulative rainfall. The atmosphere doesn't necessarily have to become dramatically worse. The ground can simply become less capable of handling what comes next. And this is where the monsoon can turn from a weather story into a system story, because now multiple things are interacting. Rainfall, soil, mountains, streams, rivers, cities, roads, infrastructure, and emergency response. Each one affects the others. Heavy rain can cause flooding. Flooding can close roads. Closed roads can slow emergency response. Landslides can isolate mountain communities. Rising rivers can put pressure on downstream infrastructure. And continued rainfall can make all of these problems harder to manage. That doesn't mean every heavy rainfall event becomes a disaster. It doesn't. But it explains why authorities pay attention when several risk factors appear at the same time. And it explains why a weather map showing another round of rainfall can matter even before the rain arrives. Because the question is no longer simply, will it rain? The question becomes, what condition will the country be in when the next storm arrives? If rainfall decreases, water levels may gradually stabilize. Some drainage systems may begin catching up. Rivers may eventually stop rising. But if heavy rainfall continues, the situation can move in the opposite direction. More runoff, higher streams, higher rivers, more urban flooding, more pressure on infrastructure. And in mountainous areas, greater risks from flash floods and landslides. Everything depends on what the monsoon does next. And that's why forecasts matter. Weather agencies don't simply watch whether rain is coming. They look at rainfall intensity, storm movement, moisture, river conditions, and the likelihood of additional precipitation. Because one forecast isn't the entire story. The forecast changes, the ground changes, the rivers change, and the risk changes with them. This is also why people shouldn't interpret a single rainfall map as a guarantee of what will happen. A map showing intense rainfall does not automatically mean every location underneath it will experience catastrophic flooding. Local geography matters, drainage matters, river levels matter, soil conditions matter, and timing matters. But when several of those factors line up, the potential consequences become much more serious. And for millions of people, the consequences aren't abstract. Flooding can disrupt normal life, homes can be affected, roads can become unusable, schools and businesses can close, electricity can be disrupted, agricultural areas can suffer losses, and communities can face difficult decisions about movement and evacuation. For emergency crews, another clock is also running, the clock of access. They need roads, they need communication, they need safe routes, they need information about where water is moving. And when flooding affects multiple regions at once, resources can become stretched. That's why preparation matters before the water reaches its highest point. Monitoring matters, early warnings matter, and knowing where water is likely to move matters. Because once flooding becomes severe, the options available to people can shrink quickly. Now, here's the question that matters most. What happens next? There are several possibilities. If the rainfall weakens, the system may gradually begin recovering. Floodwaters can recede, river levels can stabilize, and the immediate threat can decrease. But if repeated heavy rainfall continues, the situation can escalate. If mountain regions receive additional intense rain, flash flood and landslide risks can increase. If upstream rainfall continues feeding major rivers, downstream communities may face rising water later. And if urban areas receive another burst of intense rainfall while drainage systems are already struggling, flooding can happen again. So the next storm doesn't have to be catastrophic by itself. It can become dangerous because of the conditions left behind by the storms before it. That is the part people often miss. The monsoon isn't a collection of completely separate storms. The effects can overlap. One rainfall event changes the environment for the next. And that brings us back to the opening question. Why does the pattern matter? Because Pakistan isn't simply dealing with rain falling from the sky. It's dealing with a chain reaction. Rainfall, then saturation, runoff, then streams, rivers, then downstream pressure, and in cities, drainage overload, in mountains, flash flooding and landslides. One atmospheric event can interact with several different systems, and that's what makes extreme monsoon periods so difficult. The weather happens above us, but the consequences develop everywhere else, in the soil, in the rivers, on the roads, across farms, inside cities, and inside communities. That's why saying Pakistan received heavy rain doesn't fully describe the situation. The more important question is, what did that rain do? Did it soak into the ground? Did it run into streams? Did rivers rise? Did drainage systems cope? Did slopes remain stable? And most importantly, what happens if another storm arrives before the system has recovered? That is the real monsoon equation. And it is why the end of a storm shouldn't automatically be treated as the end of the danger. The clouds can move away, the rainfall can stop, but rivers can continue rising. Water can continue moving downstream, and saturated slopes can remain unstable. The atmosphere may look calmer, while the ground is still dealing with everything that already happened. That is why the next few days matter. Not because disaster is guaranteed, it isn't, but because conditions can change rapidly when rainfall, geography, rivers, and infrastructure interact. And there is one final point worth remembering. Pakistan's monsoon is not the enemy. The country depends on this rainfall. Water is essential for agriculture. It supports ecosystems. It replenishes water supplies. The problem is not rain itself. The problem is extreme rainfall arriving too quickly, too repeatedly, or in places where the landscape and infrastructure cannot safely absorb it. That distinction matters, because understanding the risk is more useful than simply fearing the storm. And that is exactly what scientists and emergency authorities are trying to do. Watch the rainfall, watch the rivers, watch the mountains, watch the cities, and watch what happens after each new storm. Because sometimes the most important information doesn't come from the storm itself. It comes from how the country responds to the water that remains afterward. So let's return to the beginning. Pakistan is drowning again. But the biggest story isn't simply that heavy rain has arrived, it's that every new storm is entering an environment that may already be carrying water from the storms before it. The ground may already be saturated, rivers may already be elevated, drainage systems may already be under pressure, mountain slopes may already be wet, and communities may already be dealing with disrupted roads and infrastructure. So the next storm doesn't begin with a blank slate. It begins with everything the previous storm left behind. And that's why the question isn't how much rain will fall. It's how much more water can the system absorb? Because the monsoon will eventually move on. The clouds will clear, the skies will brighten, but the water doesn't disappear when the rain stops. It keeps moving through the soil, down the mountains, into the streams, through the rivers, and toward the communities downstream. And that's why the real danger isn't always above you. Sometimes it's already moving toward you. If you want to follow Pakistan's latest weather developments without the hype, subscribe and stay with us. We'll keep watching the rainfall, the rivers, and the patterns that matter. Because when the next storm arrives, the headline won't tell the whole story. The water will.